tessellation is created when a shape is repeated over and over again, covering a plane or a surface without any gaps or overlaps. So say if you can take a shape and repeat that shape over and over again and cover the top of a table or the top of a desk without any gaps or overlaps with the shapes, you've created a tessellation. Sometimes we refer to this as tiling. So say these shapes, these are all regular polygons. These particular ones, squares and hexagons and triangles, these will all tessellate. So you can see how I can just take that square and keep repeating it over and over and over again. And I've created a pattern here with no gaps or overlaps, and I can keep on doing this and cover the whole screen. I can do the same thing with this hexagon here, okay, this regular hexagon. When I keep on tiling here, I'll have no gaps in my pattern and no overlaps in my pattern. Same thing with the triangle. And there we go. So you can see I could continue doing that. You'll be able to do this. You'll be able to do these kind of tessellations with a combination of transformations. Sometimes you'll just be able to translate them. Sometimes you'll need to rotate them. And sometimes you'll need to reflect them. But you should be able to take the same shape and repeat it over and over again to completely cover your surface. So you can see I can do the same thing with this type of triangle here. Okay. So I can take that and just keep on repeating it. I could take it then and sort of rotate it around so it fits together nice there like that. Need to rotate it a little more. There we go. And I could continue on and completely cover this surface here like that. If I look at it, you'll be able to tell that some shapes will not be able to tessellate. Okay, so say if I start taking this octagon, for example. Well, I'm gonna run into a point here where I'm not going to be able to fit this together. Even if I take this shape and I rotate it around a little bit, I see that the angle still won't meet, right? Or I'll have an overlap. So this octagon doesn't tessellate. And for the same reason, you'll see that this circle cannot tessellate. Okay, so these are shapes that do not tessellate. Sometimes you can use a combination of shapes, though. Say if I take two octagons combined with a square, I can create a tessellation. So if I continue on with this, I'll see that I can put two octagons there, and you can see that I can completely cover the plane using these two shapes. And on I go. A lot of times tessellations are used in art and design to create shapes. So I had a little fun with this one here, where I took a square like this and I sort of decided to take my square and cut out this shape along this side here, and then I took it and I pasted it over on this side, and I cut out this shape along this edge here, and then I pasted it on top. And because the shape was based on this square, this shape will also tessellate. So you can see here that I can use that shape and it will continue to tessellate the entire plane, or tile the plane. So have some fun with it. Take some paper, cut out some shapes, see how they fit together. See if you can start to understand why they fit together. Best of luck, and thanks for listening.